So we are discussing probabilistic inference, and we created a use case where hypothetical numbers from 130 patients in a hospital, we observe their symptoms, if they're sneezing or not sneezing, in diagnosis, if they have cold or flu. We observe 130 patients, 20 of them have cold and they're sneezing. This is joint event, having cold and sneezing, having flu and sneezing, having cold and not sneezing, having flu and not sneezing. They are referred to as joint probabilities. So joint probability of cold and not sneeze is 30 by 130. The probability of cold, a random person selected, does the person have cold or not? We will look at this number, 50 by 130. We refer to the probabilities on the margins as marginal probabilities. Probabilities in the cells are joint probabilities. Now they are related in an interesting way. What if we ask the probability that the person is not sneezing and the person has cold? For that, we will write it like this. Given that the person has cold, so this pipe sign represents the conditional information. Given that the person has cold, what is the probability the person is not sneezing? Or vice versa. What's the probability that the person has cold, given that the person is not sneezing? So these two are referred to as conditional probabilities, and they can help us infer information, answer questions based on given evidence. Now, they are also calculable from this table. So the probability that the person is not sneezing, given that the person has cold, is equal to the conditional probability of having not sneezing condition and having cold divided by the prior probability of having cold. So what shall we do? Not sneezing and cold, the number is here, right? Which is 3 by 30, let's say. And divided by the probability of cold is 50 by 30, 5 by 30. So 13 cancels 13. The probability that the person is not sneezing, given that the person has cold, is 3 by 5, which is from it came from dividing not sneezing condition and having cold. So joint probability of having cold and not sneezing divided by the probability of having cold in the whole population, right? Joint divided by marginal. So we can write it here. Joint probability divided by marginal is conditional probability. Now, interesting thing is that this joint probability is also useful when we want to answer this question. We will do what? We will say the joint probability that the person has cold and not sneezing, which is the same number, 30 by 130, divided by probability of not sneezing. So we will look at this marginal. So the marginal for probability of not sneezing is 60 by 130, and probability of cold and not sneezing is 3 by 30, this one. And the answer is 3 by 6, which is 1 by 2. So what we just did is we answered two interesting questions given an information. So this is given information. Given that the person is cold, what is the probability person is not sneezing? It's 3 out of 5. What is the probability that the person is not sneezing? Given that the person is not sneezing, what is the probability the person has cold? So half the people are not sneezing, but they have cold.